Algebra 2, Mod 8. Today is Thursday, May 14th, 2020. So top left corner of your notes that you're going to take. And you're going to listen and pay attention and go step by step and make sure you got this. You're putting 5/14/20 for the date. The title, if you remember back on Monday when we did or created our outline of functions we want to cover, review because you've been introduced to them, but really make sure detail-wise we can quickly and accurately sketch these as we head to next year. We've done linears and we did quadratics, right? We did the lines and the smileys and frownies, the parabolas, right? Now we're on radical functions, and today, just like the title says, if it's a radical function, it's a function that has a radical box, a radical box, a radical box, a radical box in it, a square root box or a radical box. And we'll start with the most basic one, y equals radical x or square root of x. Guys, if you sketch this as quick as you can, you need to at least have a mental image of what you're trying to create. And I will just say this verbally, but not write it down yet. If you've ever got a radical function, it should look like a sideways parabola, but only half of that parabola, the top half or the bottom half, depending on whether it's positive or negative. So to create that curved sideways parabola-looking shape, certainly for a curve, to see the angle with which it's curving, you've got to create three dots or three ordered pairs to plot. So, logically, watch how simple this is. You make an XY table at the left. Now, guys, listen carefully here. You do not just randomly plug in whatever 3 points you want, like -1, 0, and 1. First of all, a negative number in this problem would not make sense, would it? Are you allowed to take a negative number, plug it in for x, and have the square root of a negative number? No. Remember, that's not a real answer. It's impossible. It's an imaginary value. So think about it. Your job is to plug in first on your table whatever causes the square root box to turn into a 0. Now, in this case, since it just says square root of x, we're going to start by plugging in 0. Because that, of course, is the number that when I plug it in, is going to create a 0 under the root box. What is the square root of 0? 0. And guys, that's your starting dot on your sideways curve. You got to have a starting point somewhere. Now, how do I know what numbers to plug in? You plug in whatever two numbers you want to. Now, we've already discussed you can't plug in any negatives, so wouldn't I plug in, since that was 0, 1, and then, okay, freeze. Don't write 1 and then 2. We do not have a calculator out on our desk right now. Our goal, as I said from day one, is to graph these quickly and accurately by hand. So if I don't have a calculator, why in the world would I put a 2 in there? What's the square root of 2? I don't know, some decimal that I don't know the value of. So wouldn't 4 be the third number that makes sense here? Because if I'm dealing with a radical box, a square root, don't I want to pick numbers that are, quote, perfect squares? So the square root of 0 was 0. Let's plug 1 in. The square root of 1 is 1. Plug 4 in. The square root of 4 is 2. Oh, create perfect squares to get a nice, neat, curved shape. So, looking at these numbers, obviously I'm going to go 4 to the right, a couple to the left, a couple up, a couple down. I've got 0, 0, which is right there. 1, 1 is right there. Now, 2 dots is never enough because that looks like a line, doesn't it? 4, 2 would be right there. And I have a curved function looking like that. And it kind of looks like a parabola, doesn't it? A sideways parabola, but it's only the top half of it. And that's the shape we're trying to create. Now let's go to block 2. It says 2 radical x minus 3. That's a radical function. Your thought for next year is on these, I'm going to make a table. Okay, now guys, do not plug 0 in for x. I did not say plug 0 in. I said plug whatever number causes the radical box to become a 0. So ignoring that 2 for a second, what number would you plug in for x that would cause this square root box to become a 0? Wouldn't it be 3? Because 3 minus 3 creates the 0 that we want. So 3 is actually the first number I plug in. 3 minus 3 is 0. The square root of 0 is 0, and 0 times 2 is still 0. Oh, so when I go to graph my picture, 3, 0 is actually my starting dot. You got to have a dot to start your curve with. And it's always at whatever number makes the radical box become a 0. Now you plug 2 more numbers in, whichever 2 numbers you want. Now remember, I don't have a calculator, so let's use common sense. You're allowed to think. Wouldn't 4 be the next number to plug in? Why'd you pick that? Guys, what's 4 minus 3? It's 1. And what's the square root of 1? 1 times 2 is 2. And then, now most of you would see 3 and 4 and say, I'm going to plug in 5. No, not a good idea. Why would you plug in 5? 5 minus 3 gives you 2, and the square root of 2 is, I don't know, it's a decimal of some kind. We don't have a calculator. Wouldn't 7 be the logical next number? Why? 7 minus 3 is 4. The square root of 4 is 2. 2 times 2 gives me 4. So when I go to my picture here, I'm going to extend to my x-axis, and I'm going to go up several spots. I really don't need any room left or down because there's no negatives involved. Agreed? 3, 0, we've already plotted. 4, 2 would be right 4 and up 2. 7, 4 would be right 7 and up 4. And you've got that curved shape going right up through there looking like that. It's always a curve, never a line. Okay, let's keep rolling. Third one looks like that. Now notice on this, when you decide what number to plug in, the plus 2 is not inside the radical box, is it? It's afterwards. So I'm ignoring him for now. And I'm ignoring the negative in front. My first job is to try to make the radical, the square root box, turn into a 0. So obviously, what would we plug in for x? We would plug in 0, wouldn't we? Let's do that. What's the square root of 0? 0. Even though there's a negative in front of it, so what? I still got 0 plus 2, which is 2. Now what number should I plug in? Well, again, wouldn't 1 and 4 make sense because they're perfect squares? What's the square root of 1? Think with me. 1. But what's in front of that? Negative. So negative 1 plus 2 gives me 1. Big deal. Basic math. Think with me. Don't just copy. Now let's plug 4 in. What's the square root of 4? 2. Negative 2 plus 2 gives me 0. So on this particular graph, I'm going to go 4 or 5 to the right, a few up, couple down, couple left. 0, 2 is here. 1, 1 is there. And 4, 0 is there. So if this was my starting dot, look where my pen is, and I connect these with a curved shape, it comes down through and looks like that. Now, if you're picturing a sideways parabola, notice we've got what? The bottom half of a sideways because of the negative that was out in front. So if the radical has a negative in front of it, we're probably predicting the bottom half of our sideways parabola will be graphed. Finally, last one and we're done. Each day, this shouldn't take more than anywhere between 10 and 15 minutes at the most. Big deal. You gotta watch the videos and learn and listen with me. Take good notes, because then if you get stuck on a homework problem, you've got these to look at and refer to and remind you of how to attack the questions. It's not difficult here. It's not brain surgery. All right, here we go. Think with me. Let's say you were trying this one on your own. How do you know what number to plug in first? All right, guys, you focus on the square root box. What number would you plug in for x that would cause that radical to turn into a 0? Wouldn't it be -2? -2 plus 2 is 0. The square root of 0 is 0. And 4 minus 0 is 4. There's my starting dot. Now what number do you want to plug in? Instead of saying, I don't know, well, think. Use your brain. Don't I want to create a perfect square under there? So wouldn't -1 make sense? What's -1 plus 2? That'd be 1. The square root of 1 is 1. And 4 minus 1 is 3. This is basic math. Now what number should I plug in? Wouldn't you jump up and plug in a 2 next? And I'll think, if you say, well, why would you plug in a 2? Well, why wouldn't I plug in a 2? 2 plus 2 gives me 4. The square root of 4 is 2. And 4 minus 2 is 2. So picture-wise, I'm going to go left a few, right a few, up 3 or 4, down a few. Left 2, up 4 was our starting dot. Left 1, up 3 is our second dot. Right 2, up 2 sort of flattens out that curve, makes it look like that. I'll be darned, I did it. It's a sideways curve, just like we expected. That's how you graph radical functions. Okay? All right, hopefully that makes sense. Again, today is what? Thursday, May 14th. So your homework assignment, try 4 of these radical problems on your own, is due tomorrow, Friday the 15th by noon. Hopefully it's the 14th. You're watching this. You took your notes. You might as well sit down and do it right now. Turn it in when you're finished, and you don't have to worry about it. But at the latest, these 4 problems for your 8-point daily grade. You get a point for using the right process, as I just explained. You don't touch a calculator and just sketch what you see on your screen. You're going to lose a point for not using the process. And then you get a point for the right answer. Okay, that's how we're grading all of our functions. You got negative radical x, 2 radical x plus 1, 3 minus radical x, and radical x minus 3 plus a 2. Hit pause, copy those 4 homework problems down, and that's due tomorrow, Friday the 15th by noon. I'll see you at that point for our next section of functions that we're going to graph, okay? Great job. We'll see you tomorrow.